Good day, everyone. My name is Chukwemeka Gabriel. I'm your mathematics teacher. Today, we'll be talking about probability. At the end of this lesson, students should be able to explain outcome tables and tree diagrams, and also solve problems involving combined probability using outcome tables and tree diagrams. Now, let's get to the lesson proper. Now, before we discuss about outcome tables and tree diagram, from our previous lesson, we are able to explain what probability is all about. Like we said, that probability is the likelihood of an event to occur. Now, under this event, we will discuss different types of events that we have. I think we discussed about single event, we have compound event, we have dependent, independent event, then we have mutually exclusive event. Now, we also talk about the sample space and the sample point in your probability. That we say that the sample space is the total possible outcome of that event. Then your sample point is the outcome of a single event, depending. Now, when you're talking about simple event, your simple event contains only one sample point, while your compound event might have two or more sample points. Then we'll solve some examples under this. Then we'll move over to combined probabilities, under which we discuss about mutually exclusive events and independent events. Now, under these mutually exclusive events, we say that two events cannot occur simultaneously, and it's also known as the OR method, or the addition law. Now, we also talk about the independent event. Under this independent event, one event can occur without disturbing the occurrence of the other event, and we also term it the AND or the product law. Now, under these combined probabilities, we still have diverse ways of solving this. Now, we still have what we call the outcome tables and the tree diagram. Now, what is the outcome table? Or let's start with the tree diagram. Your tree diagrams can be used to represent the total possible outcomes when you have two or more events. Now, to draw a tree diagram, start with the outcomes of the first event, and from there, branch off each outcomes with the outcomes of the second event. Now, what do I mean by this? Now, for example, let me assume I toss two coins. Now, you already know that this is under independent event. Now, or combined, let me use combined probability. Now, I toss two coins. Now, I want to use my tree diagrams to represent this. Now, they can ask you, what is the probability of picking three heads? That is HHH. Now, for example, I want to use my tree diagram to represent it. Now, for the first toss, I can say, okay, H, which is the head, or the first coin. Let's use the first coin. The first coin will give me the what? The head and what? The tail. The head and the tail. Now, using your tree diagram, you toss it 3 times. You still have your head and tail for this one. You have your head and tail. This is the second event. Now, the third event, you still have the head and the what? The tail. Same here, the head and what? The tail. And then here, the head and what? The tail. Now, bringing all these outcomes together, we have that this will give me head, head, head. That is HHH. Then we are having our head, tail, tail. That is HTT. Then we are having tail, head, head, THH. Then we are having tail, 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 head, tail, THT. Then we are having TTH, tail, tail, head. And then we are having TTT, that is tail, tail, tail. Now, this is what we call our tree diagram. Then they will ask you, what is the probability of obtaining 3 heads? Already we have the outcome here. Now we move to what we call the outcome table. What about the outcome table? The table of outcomes is a table where the first row and first column represent the possible outcomes in each event. The first row and the first column represent the possible outcomes in each event. Now, to draw your table of outcome, the first thing that you do is to draw the table. For instance, I will assume, let me still use my head and tail. Okay, I toss 2 coins. Then what is the probability of obtaining 2 heads or something like that? Now, I want to use the outcome table now. Now, I have to make a table for the first event. Okay, I will say for the first event, I'm having head and tail. Now the second event is still my head and what? Tail. Oh, sorry. The head and tail. Then I'm having head for the first event. Then we are having head, tail for the second event. This is tail, head. This is tail, tail. Now this table is what we call our outcome table. Now let's see some examples. Now example 1. Example 1 says 2 dice are thrown at the same time. Find the probability of getting A, at least 1 5, B, a total score divisible by 5. Now we can represent this using our table of outcome. Now we draw our table. Now using the table of outcome, I can represent, okay, for the first row, I will use the first row for the first die. You already know that your die contains 6 faces. Now for the first row, okay, from the table we are having, I can say, okay, 1, 2, 3, 4, 5, 6. This for the first one. Now the second one, I'm having 1, 2, 3, 4, 5, 6. Now for each of these events, I will start from here. I'm having 1, 1 here. This is 2, 1. This is 3, 1. This is 4, 1. This is 5, 1. This is 6, 1. This is 1, 2. This is 2, 2. This is 3, 2. This is 4, 2. This is 5, 2. Then 6, 2. Then I'm having the next one, 1, 3. This 2, 3. 3, 3. Then 4, 3. 5, 3. 6, 3. Then I'm having the next one, that is 1, 4. Then 2, 4. 3, 4. Then 4, 4. 5, 4. 6, 4. Then the next one, we are having 1, 5, 2, 5, then 3, 5, having 4, 5, 5, 5, then 6, 5. The next one, we are having 1, 6, then 2, 6, 3, 6, 4, 6, 5, 6, and then 6 and 6. Now this is what we call our table of what? Outcome. Now from what we have here, we just added everything together. Like 1 plus 1 will give us 2, 2 plus 1 gives us 3, 3 plus 1 like that, 4, 4 plus 1, 5, 5 plus 1, 6, 6 plus 1, 7, like that. Then 1 plus 2, 3, like that. Add all the outcomes. Now the first question says at least 1 5, meaning that 1 must appear in one of these possible outcomes. 1 5 will appear in one of these possible outcomes. Now we check the one that has the 5. I think we are having a 5 here. We are still having a 5 here. At least 1 5. At least 1 5. Another 5. There is another 5. There is another 5 here. Another 5 here. We are having another 5 here. Another 5 here. 5, 5, 5. Now we count. How many possible outcomes? That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, before we do this, what is the total possible outcome? That should be our sample space. What is the total possible outcome from this value? When you throw 2 dice, one is 6, the other one is 6. So the total possible outcome should be 6 times 6, which is what? 36. Now, how do you get that? Counting all these possible outcomes we have here should give us 36. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So our total possible outcome is equal to 36. Now, at least getting a 5, I'll have what? From what I have from my outcome table, I have how many 5 appears in 11 places. So at least getting a 5 will be equal to what? 11 over 36. So that is the probability of obtaining at least 1 5 from this outcome table. We still have different ways of solving that. Now, from what I have there, I said, what is the probability of getting at least 5? Now, you count the outcomes with 5 on the first die. Now, which one is your first die after adding everything here? Now, let's assume this is the first die. The one that will have at least 5, I think from here down, row, then you call it your P. Then outcome with 5 on the second die, which is this one. Now, counting this, we are having 5 to 6. That is 6 plus 5, which is still 11, which will still give me 11 over 36. Now, the next question says, a total score divisible by 5. A total score divisible by 5. Now, from here, we look for those numbers that 5 can what? Divide when we add everything together. Now, this one gives me 7, 6, 5, 4, 3, 2. Then we are having 8, 7, like that. Now, we pick those points that 5 can divide. I think 5 plus 5 will give me 10. Now, this one, 5 can divide this. Which other one? We have 10. We have 6 plus 4, 2, which is still 10. We have 4 plus 6, 2, which is still 10. 5 can divide them. Which other one? We have 3 plus 2, which is 5. 5 can divide that. Then we have 2 plus 3, which is still 5. 5 can divide this one. 4 plus 1, 5 can divide this. And 4 plus 1 here. Then how many possible outcomes are we having? Do we have any other one 5 can divide? No. So we are having 1, 2, 3, 4. Then 5, 6, 7. Now the possible outcomes from our outcome table that 5 can divide at a total divisible by 5. So we are having what? 7 possible outcomes. That is 7 over our what? Total possible outcome, which is still what? 36. That is 7 over 36. Now, this is how to use your outcome table to determine the probability of combined events. Probability of combined events. Now, let's see how we can use our the tree diagram to determine the probability of combined events. For example, the next example, that is example 2. They said a bag contains 3 black balls and 2 white balls. A ball is taken from the bag and then replaced. A second ball is chosen. What is the probability that they are both blacks? One is black and one is white. At least one is black. At most, one is black. Now, I want to discuss about this replacement. Now, you notice that this is still under independent probability. Now, when they talk about without replacement, now, we discuss about dependent probability. That is, the occurrence of one will depend on the outcome of the other one. Now, this is replaced. Now, the total possible outcome there is 5 because we have 3 black balls and what? 2 white balls. Now, how do we use our tree diagram to represent this? Now, let's assume this is the bag. This is the bag. And the bag contains black and white. Now, how many times did we pick the ball? They say that they contain 3 black balls and 2 white balls. Then a ball is taken from the back and then replaced. Then a second ball. So 2 times. Now, 2 times. Then we are having another. For the second event, black and white. For the second event, we are having black and white. Now, this is the first event. This is the second. Now from here now, picking a black ball. I think how many black balls do we have? We have 3 black balls. So this one will give me 3/5. This one still gives me 3/5. Now this, picking a white, we have 2/5. This still gives me 2/5. Now picking a white here, I'll still have 2/5. Picking a black here, I'll have 3/5. Now from this, we are having probability of black, then probability of white. Then we are having white-black here. Then probability of picking white. Now from here now we can answer the question. They say, what is the probability that they are both blacks? Meaning that picking black. They are both blacks. Okay, let's explain this. Now when you pick the first one, it is black. And the probability of obtaining a black is what? Is 3/5 because we have 3 blacks. So we have 3/5 for the first case, picking a black. Then you replace and pick another one, meaning you picked another black. So you are having probability of picking a black and a black. That is black. So I'll have 3/5 times what? 3/5, which should give me what? 9/25. That is the probability of picking 2 black balls. Now the next one, they say one is black and one is white. Now we have 2 possible ways of doing this. Now one is white and one is either you pick the first case, you obtain a black, pick the second one, obtain a white, or you pick the first case, you obtain a white, pick the second case, you obtain a black. Now, what do I mean by that? We are having black-white here, white-black here. Now, we first look for the probability of picking black-white or probability of picking white-black. Now, from here now, we say what? Probability of picking black-white will give us 3/5 times what? 2/5. That is 3/5 times what? 2/5, which should give me 6/25. Now, the next one, white-black. White-black, that is 2/5 times still 3/5. Probability of picking either white and black will give me what? 2/5 times what? 3/5, which is equal to 6/25. Now we are having probability of picking black, white or black. Since we have all, they are mutually what? Exclusive, so events. So I'll have P black white or P white black will give me what? 6/25 plus 6/25, which is equal to 12/25. So that is the probability of picking one is white or the other is what? And the other is what? One is black and the other is what? White. Now the next one say at least one is black. At least one is black. Now we go down to our 3 table. At least one is black. Now from the 3 table, at least one is black. It's either black or black-white or white-black, not white-white. At least one is black. So black must appear in anyone, either one. Now, with this, we have black-white. So probability of picking black or black-white or what? White-black will give us what? At least one is what? Black. So I'll have probability of picking a black will give us black plus probability of picking black-white plus the probability of picking white-black. Now, we have solved the probability of picking black, and the probability of picking black gives me 9/25. Now, we have the one of picking either black-white or white-black, which we already have here, which is 12/25. So the probability of picking at least one black will give us what? 9/25 plus 12 over 25. Now, this one has covered the probability of picking either a black and a white. Now, which is equal to 9 plus 12 is 21 over 25. 21 over 25. Now, the last question there says, at most one black. At most one black. Now, at most one black means either one is black or none is what? Black. Either one is black or none is what? Black. That is, one is black or two are what? White. Now, what does that mean? It means that from our tree diagram, either one is black or none is what? Black. At most black. So, meaning that we discussed what? Black, white, and what? White, black. It's either we have black, black, or the rest are what? White. So, what is the probability of picking our black, black? Okay, let's start with white, white. Okay, wait. At most one black, sorry. At most one black, meaning only one black will appear, not two black. At most one black, only one black will appear. So, probability of picking black, white, or white, black, plus or white, white. Now, from there, we already have the probability of picking black, white, or white, black, which is what? 12 over what? 25. Now, what is the probability of picking white, white? Already, here is 2 over 5. Here is 2 over 5. Now, the probability of picking white, white will give us 2 over 5 times 2 over 5, which is what? 4 over what? 25. Now, the probability of picking either at most black will give us what? At most one black will be equal to what? 4 over 25 plus either 12 over 25, which should give me what? 16 over 25. Now, let's go over to the lesson evaluation. Now, from the first question, I said, if 3 cards are chosen from a pack without replacement, what is the probability of getting at least 2 spades and at most 2 spades? Now, we can still use our tree diagram to represent this. Now, you already know a standard deck card. How many we have there? I think we have 52. And I think inside that 52 is divided into 4. Yes, we have the hearts, then we have the spades, we have the clubs, and then we have the diamonds. Now, each of these 4 contains 13. Like the heart, we have 13, then the diamond 13, the clubs 13, and then the spades 13. Now, inside that, you already know 30, 13. So, meaning if you are picking a spade, at least 2 spades with your tree diagram. For example, what do I mean by that? You have the card already, the spade. Since we are dealing with spades now then we term the other one non-spade. So either spade, non-spade, spade, and non-spade. This one contains the rest of the card because it's divided into 4. Now this one will give me 13, and the total is what? Over 52. Now, without replacement, meaning that if you pick another one, you are having 12 over 52. And how many times did we pick? 3 times. So we are still having spade and non-spade. This one will give us 11, this 51, this 11 over 50. Like that. Spade, non-spade, spade, non-spade. Like that. Now, with that, you have, this one will give me SSS. This one, like that, SSN, 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 then SNS, then we're having SNN, then this one NSS, this is NSN, this NNS, and this will give me NNN. Now the probability of picking at least 2 spades. Now check the one that at least you have 2 spades. I think the first one will go 2 spades. Now we have SS here. We still have SS here. We are only having 1 spade. They say at least 2 spades. We have SS here. Now you calculate their combined probability, and that will give you the probability of getting at least 2 spades. At least 2 spades. Then they say at most 2 spades. At most 2 spades. Now You check out the same procedure, and remember we said without what? Replacement, meaning as you are adding, as you are going, the thing will be reduced. You remove the card, you did not replace. So the total possible outcome will actually what? Reduce. Now with this, we have come to the end of today's lesson. Thank you for watching. My name is Chukwemeka Gabriel. Till next time.